In this presentation, because we've had a number of requests, we're going to be doing two procedures on a Toyota Sequoia immobilizer from the year 2003 to 2007. This particular immobilizer uses a different styled EEPROM package. It uses a DIP package. DIP, D-I-P, stands for dual inline package. So we're going to be doing first a Reflash, and second we're going to do a Cloneout. So if you haven't already seen our previous videos on Reflashing and Cloneouts, you might check those out. But let's just proceed. So we're going to remove the immobilizer from its case. We're releasing its little clips on the side here. And we're going to take it out. Slide out of the box. And the EEPROM with which we will be working is right here. This says, printed on the top of it, 93C66. But in circuit, it's a 93C66 8-bit or a 93LC66A, which are both the same part. Also, on this particular immobilizer, this particular microcontroller, which is right here, will many times continue to run. And with our system, even though we specialize in in-circuit programming, the fact that it runs even on our lowest operational voltage that we can apply to the module, it may or may not run. Sometimes it does, sometimes it doesn't. But to be on the safe side, we're going to disable the processor by grounding the ceramic resonator, which is right here. That's that little blue component that looks like a squished M&M. And that serves the same purpose as a crystal. And the reason that, matter of fact, it even says XT1 on the circuit assembly. The reason manufacturers use these is that they're cheaper than crystals. And if you don't need a lot of accuracy and the frequency at which the processor runs, you can get away with using a ceramic resonator in place of a crystal. You'll notice that there are 3 pins that come out of the ceramic resonator package. If this were a crystal, it would only have 2 pins. So the center pin on this particular component is ground. So in order to disable the processor, you can connect either the center pin to either side, and that will disable it, or you can connect a ground the probe to either side. And what we'll do is we'll connect the ground probe to the inside pin. This pin on the, when I say inside, I mean this side right here. And that'll stop the processor from running. Now when we connect to this assembly, the Automotive Kit 1, which is what we're going to be using for the demonstration, does not include a dip clip. Okay, the dip clip from Andromeda Research is an option. You can purchase it on our website. But what we include are some probes, which can easily be attached to the part. And I'm going to attach those probes to the part now so you can see how that's done. Okay, pin number 1 on this dip part is marked with a dimple. That's pin number 1 right there. It also has silk screened on the circuit assembly, A1, and the component designator is IC2. And point something out to you a little bit later, once I start our software, why, how you would know that using our software. So we're going to use the probe set. It's right here, and for those of you that have seen our other videos, you know we use colored probes, and the reason we use colored probes, I've said it in so many videos that you probably get tired of me saying it, is that each color represents a number. So we have brown, red, orange, yellow, green, blue, violet, gray, which goes 1, 2, 3, 4, 5, 6, 7, 8. So each color, each appropriate color is connected to the pin, the appropriate pin on the part. So that means that brown's going to go to pin 1, red's going to go to pin 2, etc. So I'm going to hook these up, and you can see how long it takes to put one probe on. I'm just going to put it on pin number 1, which is right here. There we go, pin number 1. And I'll hook the rest of them up. and return to the video when I am done. So here are the probes attached to the part. You'll notice it goes brown, red, orange, yellow down the left hand side, brown attached to pin 1, and then it goes across to green, blue, skip a pin, and then gray, because the violet probe is going to be hooked to the ceramic resonator in order to disable it. So let me attach that, and you can see how that works. Okay, here's the violet probe attached to the ceramic resonator right here, and that will prevent the processor from running while we access the, or in this case, reflash the part. So now we're ready to go ahead and start the EEPROM Plus software, hook up the probe set cable to the in-circuit adapter, and I will show you how to identify that part in the IC before we perform the reflash. So let me go ahead and get that set up. Alright, so before we connect the probe set to the in-circuit adapter, we're going to start the software. This is so that the connection to the part does not interfere with the starting and locating of the programming unit. So we'll double click the EEPROM Plus icon. There's the opening screen. We identify the part. Now I'm going to show you something. We're going to select the 93C56, which is 56, which is the wrong part. Now why would I do that? Because I want to show you how the librarian can assist you in selecting the correct part and also identifying which part you're working with and other things. So the next step, I'm going to press the space bar or any other key and clear the information display. Again, this just shows you how to set up the dip switches on the programming unit and the dip switches on the adapter, and it also tells you, if you look in the lower right hand corner, plug or device position left, 93XX. So it tells you where to attach the plug. So I'm going to hit the space bar, that's going to go away. I'm going to hit path, P for path, because I'm going to work in the Locksmith directory. So now we're going to use arrow keys. We're going to go to Locksmith, which is right there. I'm going to select it by pressing enter. Going to press L for librarian. So now we're going to go down to Toyota, which is right over here. Going to press enter, and when we press enter, the mode changes from browse, which allows you to move around in the upper pane, to view, which allows you to move around in the lower pane. And we're going to go down until we find the Sequoia, and that is going to be right here, Sequoia 03 to 07. So I have put the cursor, which is your selector, on that line. But what I want you to see is, if you look across this line, you can just, I'm going to move the cursor so you can see it, use it as a pointer. You encounter things. There's the Reflash file name. There's the part number that is actually required in order for this reflash to be successful, or to access to be successful. Okay, so it's on the line. That, as we pointed out in a previous video, if you choose the wrong part, when you execute a reflash through the librarian, we will choose the correct part for you. That way you won't be confused if you have a failure in your reflash because you've picked the wrong part. So we picked the correct part there. Then we tell you where the immobilizer is located, behind instrument panel, and lastly, the part to which you're connecting the identifier is IC2. Okay, so those are things that are all provided. So if you want to confirm that your information is correct, you're hooked to the right part, the part number is selected, you can use the librarian entry line to make that determination. Okay, so now we're going to go ahead and perform the reflash, and as I said before, the instructions for that are at the top of the screen. But right now, if you look at the status line in the center, it says the mode is view, which means we're working down in the lower part of the librarian panel. And now we're going to press F6. And when we press F6, the librarian processes the data that's on the line where the cursor was located, or the selector was located. So it executes and processes all of the information which was on that line. So the mode now changes to program load, which means you can either program the file into the part, or you can load that particular file into the buffer if you wanted to look at it. Okay. There's the file name for the reflash, and then to the right it says F3 to program, F4 to load. Alright, so at this point we're going to press F3, and now I'm going to connect the cable, the black plug from the probe set, to the in-circuit adapter. So here's the brown wire on the right, black plug goes onto the 93XX headers. And I'll scoot this over, you can see the probes and the programming unit. And now I'm going to go back to the computer. I'm going to press P, and we'll see if everything works the way that we expected it to work. Wrong keyboard. P. Program complete, data verified correct. So we have reflashed this module. It is now ready to be installed in the vehicle, and have it learn new keys, and you can then synchronize it with the resync block to the ECU, and the car will start. So that is the end of that demonstration for reflashing the Sequoia with the probe set attached to the immobilizer. Program another set? No. Alright, I've disconnected the probes from the immobilizer, and I also, since I reflashed the immobilizer, I saved the file previously so I could put it back so you could see the cloneout work. So now we're going to perform the cloneout procedure, but we're going to use the clip. Okay, as I said, the clip is an optional connection option that you can purchase from our website, but you don't need it if you purchase the kit, because the probe set allows you to work with the part that's on the immobilizer. So let's put the clip plug onto the in-circuit adapter. The clip has a red mark on it indicating pin 1. So all we have to do is put the clip over the top of the part and make sure it's aligned and nice and tight. And I'm going to show you something that we can do here. Go back to the computer display, and now how do I know the clip is actually attached to the part? Meaning, how do I know there's not some crud or some other contamination, humidity sealant, whatever on the pins? Before I try to do my cloneout, it might be nice to know that. Okay, well, you just go ahead and try and read it, which would, give you the same result. But you can also use the buffer editor and say, let's have a quick check. So I'm going to go to Command 5. But now I'm going to use a function called Quick View. Quick View does not read the data into the buffer, it just reads the data from the part and puts it up on the screen. So it's a convenient way for you to tell whether or not you're actually connected to the part. So I'm going to press Q, and we should see information from the part appear on the screen. There it is. Okay, so that's a good indication that we are attached to the part, and we can go ahead and read the data into the buffer and perform our cloneout. So to read the data into the buffer and guarantee a good read, we're going to use the G command, which is get valid data. So all you do is press G, and it says part and buffer do not match. And why would that be? Well, that would be because the processor is running. So this is a case where we have not disabled the processor with the purple probe, and that's what you get. meaning that we're connected to the part, but we're getting what's called data collision from the processor accessing the part at the same time that we do. Now, we'll just walk through this so you can see what may work. Well, let's just see if it does, and that is I'm going to clear that information display. I'm going to go back to the camera. I'm going to set our in-circuit voltage down to 3, which is the lowest that we offer. We'll see if that would allow us to read the part without interference from the processor. So let's go back and do G again. And it did. Okay. By setting it to the lower voltage, the processor on this particular immobilizer it didn't run. It is no longer running. So we were able to access the part. It's one of the things about our package is by giving you the option to change the working voltage. Sometimes you can get away with not disabling the processor because we bias the assembly in a way where the processor doesn't run but the memory part still functions. But I'm going to show you something else, and that is how to disable the processor since using the clip you don't have the purple probe. Alright, I'm going to set the in-circuit adapter working voltage back up to 3.6, and we'll see if we no longer get a good read. So let's press G and see what happens. Okay, part and buffer do not match. Alright, now the processor is now running, so what I'm going to do is I'm going to disable the processor with this. This is a jeweler screwdriver. Okay, you can use a pocket knife, you can use whatever you can find that is metal, and you're going to stick it in between pins 14 and 15 on the processor, just like that. I've got this screwdriver wedged in between pins 14 and 15. So now, if I go back to the screen and I press G, we get a good read. Why? Because shorting pins 14 and 15 does the same thing as the purple probe on the immobilizer. So if you have the clip and you can't get a good read and you set your in-circuit adapter to the lowest voltage 3 and you still can't get a good read, then you can just put something metal in between pins 14 and 15 and you can see that you get a good read. Let me zoom in so you can see which pins are 14 and 15. Alright, if you look, my fat finger in the way, you can see I got the jeweler screwdriver stuck in between pins 14 and 15. Pin 16 is the one at the very end right here. So it's 16 and then 15 and 14. So I just had the jeweler screwdriver jammed in between those two pins. But as I said, you can use anything. But you got to hold it there while you're doing the read. And that's one of the convenient features of the get validated command is you can use one hand to hold the thing in place and use the other hand to hit the G key and read your data, and once your data is in the buffer you can take it off and your data is there for you to save. So that's just a trick, something that you might be able to use. So now let's go back and save this file so we can complete our cloneout. Okay, to complete the cloneout, what we want to do is we want to save the data that we have in the buffer to a directory on the hard drive. And for those of you that have watched previous videos, we created a directory or a folder called Cloneout. So let's see if we can navigate the Cloneout here. We're going to exit the editor. We're going to press P for path. We're going to navigate to Cloneout. We're already on Cloneout. Okay, so to select Cloneout, the current path is already Cloneout, so we're already pointing to the right place to save. So I'm going to go ahead and save this using Command A from the main command list, because in the past I've saved using the Command A from the buffer editor. Okay. Before we do that, let's look and see what files are in Cloneout. Okay, so to see the files that are in a directory to which you are pointing, you press D for a directory of files, and we have a previous demo file called Forerunner forerunner.bin that we used for in a previous demonstration on a small black box immobilizer. But now we're going to go to press escape, Command A. Current path is C:\cloneout. That's where we're pointing. Enter file name. Let's call this sequoia.bin. Sequoia.bin. Press enter. Save defined buffer range, which is the size of the part. Size of the part is 0 to 1 FF, and the defined range is 0 to 1 FF. So we're going to save defined buffer range. Yes. File save complete. Now, if you want to know that it's there, if it's there, let's press directory of files, and we have sequoia.bin. Okay. So that's saved, and when you're ready to do your cloneout, all you have to do is navigate to sequoia.bin, or navigate to cloneout, and load sequoia.bin into your transponder programmer and make the key. You do that, there's no 30-minute delay, no resynchronization. It's a much faster procedure. So that pretty much wraps up this demonstration. We use the probe set in order to do the reflash, and then we use the clip in order to do the cloneout. So that's really all that I wanted you to see here. You also learned a trick or two. So I hope you found this helpful. And as always, we appreciate you watching. And as always, if you would like information on our products or to discuss our products with us or anything else, we're always happy to help you out. Information is on our website, arlabs.com. And as always, we thank you for watching.